Hello, Rio Grande third graders. It's day 4, week 13 of our DMA. We are going to go over our solutions. Please make sure that you have this done before we meet live today. There's going to be a discussion question at the end of this, so make sure you stay on till the end. We're going to look at our first table. We are looking at the table and it tells us to multiply by 2. So this is an input-output table. So whatever we're doing to our first number, which is in the column, we're going to multiply by 2 and get the output. So basically it looks like this if we were to put it into an equation. So if I were to multiply 3 times 2, that means I have 3 groups of 2, and then I would have 6, because I have 2, 4, 6, 3 groups of 2. Add another group of 2 to 6. Now I have 4 groups of 2, and that would be 8. And yes, you will notice a pattern here as well. But again, we also want to make sure that we're going input to output. 5 groups of 2. We're going to add another group of 2, and now we're at 10 because we're going to add another group of 2 here, and now we're adding another group of 2, and 6 groups of 2 is now 12. So our rule is to multiply by 2, and these are our input, and these are the output. So again, we're looking at the pattern going from input to output. Our next set of problems are an equation that we haven't really gotten to this standard yet, but it's similar to what we've already been working with on our multiplication facts. So I'm going to use some base 10 blocks here to kind of demonstrate this for you. So I have 20 groups of 5, or if I switch the factors and use my commutative property and switch the order, I could also solve this by saying 5 groups of 20. And I think it would be much easier if we do 5 groups of 20 instead of 20 groups of 5. I mean, I guess you could do 10 groups of 5. You could break this up as 10 and 10. And you could use the distributive property, which we've also talked about, and do 10 times 5 plus another 10 times 5. And 10 times 5 is 50. And another 10 groups of 5 is 50. So here are the 20 groups of 5, and that makes 100. But if I wanted to show this as base 10 blocks, I could use my base 10 blocks, and I could have, here's a group of 20. So here's one group of 20, and that's 20. I'm going to zoom out here real quick. One group of 20 is 20. I have another group of 20, and now I'm at 40. So 20, 40. It's just like counting by 2s, but we're counting by 10s, right? 2, 4, 20, 40. Another group. So I have 3 groups of 20. 3 groups of 20 would be 60. 4 groups of 20. Now I've got 4 groups of 20. 4 groups of 20 would be 80. And now I have one more group of 20. Now I'm at 5 groups of 20. And 5 groups of 20 would be 20, 40, 60, 80, 100. So just like we did here, just like we did over here, we could say 10 or 50 plus 50, 5 groups of 20 is going to be 100. Now, I could use this 5 times 20 to help me get 6 times 20 by adding one more group of 20. So if I were to take one more group of 20, which I'm going to do here on my model of using my base 10 blocks here. I'm going to zoom out a little bit more so that you can see the whole. So here's my 5 groups of 20. That's 100. Another 20. Here's another one group of 20. Now I'm at 120. So 20, 40, 60, 80, 100, 120. So I can come over here and I know that one more group of 20 added onto this 100 right here is going to be 120. Now, I could do the same thing here. I could take this I could take this 5 times 20 and add another 2 groups of 20, which I already did with my, so I'm using my base of 5 times 20 to add another group of 20. And we know that 5 groups of 20, so right here I have my 5 groups of 20. Those 5 groups of 20 are 100. And then, so I could say 5 groups of 20. And then I'm going to take another 2 groups of 20. And another 2 groups of 20 is going to give me 40. And 140 together makes 140. So basically, I'm still using the idea of the distributed property. I'm starting with something I already know and adding on to that. So now I know that 7 groups of 20 is going to be 140. Now I can use my addition. So I'm adding 2 addends. These are called addends. And we are going to add them together to find the sum or the total. Remember that you can have your equal sign on the opposite side. You do not have to have your equal sign on the right side. It can also be on the left side, just as long as these 2 sides are equal to one another. So let's take a look at this. I'm going to start with the break apart strategy, and then we'll move to the algorithm. So I have my hundreds place, and I'm adding my hundreds, and I know 500 plus 300 is 800. I know that I have 80 and 80. Now, remember, just like 8 and 8, 8 and 8 is 16. So if I have 80 and 80, and if I think about 50 and 50, 50 and 50 is 100. 60 plus 60 is 120. 70 plus 70 is 140. 80 plus 80 would be 160. So that tells me I'm regrouping. I've got 2 more 10s here to make this 100, and I've got 60 here to add on to this 100. So just to remind you that 80 and 20 is that one more group of 100 right here. Now I can take my ones, and 4 and 1 is 5. And now I can take and put these all back together with my hundreds. These are my 10s, even though it has regrouped to a new 100, and my 1. So 800 plus 100 is 900. 900 plus 60 is 960. And then 5 more is 965. So my sum is 965. I can also use my idea of using the algorithm. So again, I'm going to rewrite this, but this time I'm going to use my place values and make sure that they are lined up with one another, because we don't want to add ones with 10s, because we want to make sure that we're adding the same amount or same values together. So 3 and 1 more is 4, which is, sorry, I miswrote that. I was talking and I miswrote my addend. So 4 and 1 is 5, which is what we had here. We have 8 10s and 8 10s. 8 10s and 8 10s is 16 10s. 16 10s is the same as 160. Here's the 60, and I'm regrouping the 100 here to the hundreds place. 500 plus 300 is 800 plus 1 more 100 from right here is 900. So I regrouped it here. This 100 right here is now right here in the algorithm. And I still ended up with 965. So 2 different strategies here. Make sure that you are able to understand both. It's very important to be able to understand both of them. Our next set of problems are multiplication problems. We are looking for the total objects. We have groups. We have the same number in each group, and we're looking for the total. Remember, we can use repeated addition, skip counting, and just to double check our work. So 3 groups of 6 would be like saying 6 plus 6 plus 6. And if I was showing this as a tape diagram, 6 plus 6 is 12, and 6 more is going to give me 18. So these are my total, 18. Just to remind you, you can switch your factors and you can still end up with the same product. So if I had 6 groups of 3, I could count by 3s, 3, 6, 9, 12, 15, and 18. So 1, 2, 3, 4, 5, 6 groups of 3 have been added together to, or been skip counted to get 18. 3 groups of 3. Now actually, I could have used 3 groups of 3 to help me get 3 groups of 6. How? Well, let's think of 3 groups of 3. So I have my rows. My rows are the same, but I'm taking and adding 3 more onto these rows to get 6 in each row now. So this 3 times 3, I could use it and double it and get 3 groups of 6. And 3 times 3 is 9. And so 9 and 9 would give me my 18. So that's just another way to think about using your 3s to help you get 6s by doubling them. So 3 times 3 is 9. So that goes with this array right here. And 2 groups of 8. 2 groups of 8. So if I were to draw rows, and I have 8 in each row, 1, 2, 3, 4, 5, 6, 7, 8. So 2 rows of 8, 2 groups of 8 is going to give me 8 plus 8, and 8 plus 8 is 16. Today in our discussion, in our warm-up, or actually on our startup page today, you're going to be asked this question. And it goes with this problem that we just said. How can you use 2 times 8 to help you find 4 times 8? So today when we meet in class, that's going to be the question of the day. How can you use 2 times 8 to help you find 4 times 8? So we're going to discuss that. You're going to put that in the chat, but we are not going to click enter until I let you know when to click enter. So think about that when you get on today for our live meeting. Again, it's Thursday, so have a great day, and I'll see you at live meeting today.